let us now check how the concept of continuity applies for a modulus function. Now, the question is f of x is modulus of x divided by x when x is not equal to 0 and 0 when x equal to 0. Let us do the left hand limit to start with. So, what is your left hand limit? Left hand limit is limit x tends to 0 minus of this function, correct? Modulus of x by x. In this question, for left hand limit also the same function, right hand limit also the same function, because when x is not equal to 0, the function is only this. Okay. Now, limit x tends to 0 minus of this. Now, our next step is going to be limit h tends to 0. Wherever x is there, replace by 0 minus h, because it is going to be a number smaller than 0. This is same as limit h tends to 0, and h is a positive number, very small positive number. Therefore, 0 minus h is going to be minus h divided by minus h, and when it is minus h, and as h is positive, this is going to be h divided by minus h. When you substitute h is 0, you get 0 by 0. And when you have 0 by 0, it is called as indeterminate form, and we are not supposed to continue the sum in that way. So what we will do now, we apply some tricks like h and h are common. You can cancel out that h. Because h is tending to 0 and h is not equal to 0, we are allowed to cancel this h. So when I cancel this, I get the left hand limit as 1. So when I want to do for the modulus function at 0, from the left hand limit, from the left hand side, the left hand limit is equal to negative 1. Now we are going to check the same thing for the right hand limit. So what is going to be the right hand limit? Right hand limit is going to be f of limit x tends to 0 plus of f of x. And what is your f of x? It is the same function, modulus of x divided by x. And 0 plus is a number little more than 0. We have limit h tends to 0, modulus of 0 plus h divided by 0 plus h. This is same as limit h tends to 0, h divided by h, and this is equal to 1 because h and h cancels. So what is your right hand limit? Your right hand limit is also equal to, is equal to 1, which is not equal to the left hand limit. But when you check f of 0, you can see from the definition, this is equal to 0. So you understand, left hand limit is not equal to right hand limit, as well as that is not equal to f of 0. Therefore, the function is discontinuous and x is equal to 0. One thing please remember, when you do left hand limit itself, I got it as minus 1. So I know when x is 0, it is 0. So already from the first left hand limit itself, I know the function is not continuous. So with this itself, as left hand limit is not equal to f of 0, I could have told discontinuity. But just for the clarity of thought, I did the right hand limit for you. But this is enough to show that the function is discontinuous. Hope this is clear for you.